Hi everybody, this is Kwabena with OpenMV, and today I just want to talk to you about an exciting new feature. We've got OpenMV integrated with Roboflow now. We promised this a while back that we'd have the ability to export YOLOV8 models from Roboflow, but it's finally working. So I just wanted to go over that today and just talk a little bit about what this means. So first, what is Roboflow? Roboflow is going to be an all-in-one platform that you can use to train AI models. So what they've got more or less is an online system that will let you collect data and then draw bounding boxes and more or less be able to create custom YOLOV8 models that can be used for object tracking. It's super powerful to have this because without it, we're just going to be able to give you canned demo models, but with Roboflow, you can actually create useful AI models for real applications. And Roboflow is trusted by many companies. They're a great partner, and they're super excited to see what you can do with your OpenMV cam. And they were excited to get the integration done. So let's talk in more detail about how it works. First, the way this operates right now, just to get started if you want, Roboflow features a universe of image datasets that are available. And so there's lots of different projects that are out there that people have created that you can borrow to kind of get started on thinking about your first kind of AI model and so on and so forth. We're starting with the license plate recognition data set here. And so with Roboflow and using their universe option, instead of having to collect all these images yourself, you can get started with a basic a basic library of images. This, and for example, this data set, it already comes with 10,000 plus images. And so if you click Use Dataset, that'll import it inside of your application, and you'll be able to work from that. So let's check out what that looks like. So we're going to fork dataset here, and we're going to send it to our repo. And once we do that, it's going to copy the data set over and copy the images and give you a way that you're going to be able to use this system for whatever you'd like. As I said, Roboflow has these images in the cloud for you. So it's copying images now. Give it a little sec. And boom, we're done. Roboflow has copied the data set here. Okay, so now, once we've done that, we can decide to train a model and so on and so forth. Let's just get the zoom appropriate for the video. Okay, great. So right here, we can give it a name. So let's call this test 2. And we select the source images. That's all the stuff we're getting from all of those 10,000 ones we just got from Roboflow Universe for free. And then we can do test and train splits, so you can actually select that. Just a little bit of background on that. Basically, you want to have your training set and validation set and test set such that they're all different representations of the data. So the train set is what the AI model will actually be trained on, and then it's validated on achieving a certain target based on the validation set. And then the test set, the AI model never sees until you actually test it in the final application, more or less, or test it right before deployment. This is kind of best practices on how people set up AI model training. Finally, Roboflow actually supports pre-processing kind of online. And so using this, you're going to be able to add different pre-processing steps like, basically cropping the image, resizing, adding grayscale, modifying things, etc. So auto-orientate is a nice pre-processing step. You might also want static crop, for example. That one, though, it looks like we'll get rid of the license plate, so maybe not that. Maybe dynamic crop? No. Anyway, so there's a lot of different options you can have here for pre-processing it. And then finally, after pre-processing, you can actually select augmentation steps that will pretty much just go through and mess the image up to make the AI model more resilient. And so we can add all kinds of great things online, like rotating, cropping, sharing the image, etc. And so these are all available for you to make your AI model more robust, more or less, change the exposure and brightness and etc. And so you can go through and add all those pre-processing steps. And then finally, you'll create the model. Now, a trick here is that Roboflow has a great online training system that works in the cloud for you. But it does cost money, though. So you do have to sign up for a Roboflow account, which will be a certain price per month. And then based on the level of images and the actual, quality of the work you're trying to do, you're going to actually need to get some, tokens to be able to handle that. So as I added those pre-processing steps in augmentation, for example, that starts to blow the number of images up. And so, to get the most robust model, for example, we need to upgrade to a higher end account. And training on 100,000 images, for example, takes a lot longer than training on 10K. Anyway, and so once you're done with all of this, and you kind of selected the parameters for what you'd like to do for your AI model, you can go ahead and create it. And just give it a sec as it goes through. And so it's super cool that Roboflow has set all this up to run on the cloud. So this used to take a lot of pain and suffering trying to do this on the desktop. And so they've got everything you need to really make this a fast and efficient process for training your own AI models. Obviously, if you have your own data set and you're not starting with 10K images, it might be a little bit, you might be able to do a little bit better. Well, you may not have to worry about the cost of how much these things would be if you're training a 10,000 image data set model. But this is kind of realistic on anyone who's trying to do something that's professional grade. And so it's awesome to use Roboflow in that this is a professional grade tool that's really going to let you actually make real applications if you're OpenMV Cam. Finally, once you're ready and you've got everything set up with the test validation, pre-processing, and post-processing arguments, you can click Custom Train. Now, for the different AI models that we're going to use here, the OpenMV Cam right now can run YOLOV8 models. So it's not going to be able to run the new RF Deader by Roboflow. That'll come in the future, though. We will be able to have post-processing support for that, but right now we have YOLOV8. As for YOLOV11, we'll offer support for that very soon on the OpenMV Cam also, so you'll be able to choose between these two if you like. And YOLOV12 and YOLONAS, we probably will implement those in the future next year. But for right now, you just choose Roboflow 3.0, YOLOV8 compatible, and click Go. And then finally, for the size of the AI model that you're going to run or want to run, remember the OpenMV Cam is a microcontroller, so generally you're going to want to choose the fast option. You can actually choose the accurate. That might fit. That's a YOLOV8 small model. It's going to be about 10 megabytes or so in size. But that's going to probably run at something like 5 FPS or less. And so we recommend the fast if you want something that's going to run at 13 to 30 FPS or so. Finally, they give you an option to pick a checkpoint. So base off, start the model with weights based off MS COCO or people detection or vehicle detection. And so we're starting it off of MS COCO, and you can start training. Now, the trick here is that this is going to take a while. These are actually, this is desktop, well, this is, production grade. These are production grade tools. And so when it's actually training here, it's actually doing the real thing. So this is going to take on the order of 5 hours. And so we'll not run this video that long, but we'll come back to it. So you can see right here, oh, not even 5 hours, 9 hours actually. So this is going to take a while. But that's what it looks like to actually do production grade ML and computer vision. Great. So that's going right now. And let's skip ahead to an already pre-trained model that we have instead of waiting for that to go back. So let's go back to our license plate recognition that we trained a while back. And we can see some results here. First, you may notice that the metrics are kind of high, 95%, 98, and 94. That typically means the model might have overfit on our data set, so we shouldn't expect amazing performance here. You probably actually want to see the model being somewhere close to 90 or 80% accurate, because getting up to 95 means it kind of memorized everything versus actually recognizing everything in the data set. But once the model is trained, we can go ahead and export it. And so the new feature that Roboflow offers for OpenMV is the ability to deploy to third-party platforms. So if you go to the Deploy tab on the left, and click Deployments, and then go all the way down to the bottom, you have Deploy to third-party platforms with the OpenMV and SnapAR Lens Studio. So you click that, click OpenMV, and download files. And this is going to download the OpenMV license plate recognition file. So from that, we're going to be able to actually export that to our OpenMV cam so that we can train a neural network using it. All right, let's check that out. All right, so now we're going to try to load the model onto the OpenMV cam using OpenMV IDE. All right, so let's check it out. We got our OpenMV cam AE3 here. We're streaming some video. Let's check out how this looks to get ROMFS on board and get this model there. So select Edit ROMFS, High Performance File System, and that's going to open up the DFU util bootloader to reset the camera and suck out the ROMFS partition and get that on board our system. All right, once this is loaded, we're going to have access to the ROMFS partition on board, and we can see there's a bunch of AI models there. And so let's add that file, the license plate recognition, and click Optimize for Performance. And so this is going to run the ARM Vela compiler on your computer, and as you can see, it went through and it's perfectly able to compile the model, and we're at about 98% of the operations fit on the CPU. Will fit on the NPU, and only 5% of them are on the CPU. And we see it's using about 33% of our heap of 4 megabytes. So click OK there, and then let's just give this a more sane name. So let's just do license plate recog. And we're just going to keep track of that and commit it. And so now this is going to write that file back to the OpenMV cam. And once it's done, we're going to be able to use that AI model and run inference results on it. So we'll check that out in a sec. All right. So our license plate AI model has now been transferred to an OpenMV cam, and it's been put on the ROMFS. And I've opened up a YOLOV8 example script to get started with. And so this example script is set up for us to be able to run a YOLOV8 model. Now, by default, that's going to have a person detection model on board. But instead of detecting people, we want to detect this custom AI model that we trained. And so we just replace the name here with the name of the file that we put on the disk. And this sets up the post-processing so that it's going to be running a YOLOV8 model. Now, for this initial release of this feature, we don't have the label export built in. So you do actually need to, excuse me, you do actually need to export the labels manually. But Roboflow will be building in, it will be modifying the system such that it exports both the model and a zip and a .text file with the labels inside. So once we do that, we have to kind of manually add this little line here just to set the labels on the model. But once we have that going on, we can actually run our YOLOV8 model and see what it looks like. So you can see we're getting about 13 FPS here, which is pretty decent for detecting license plates on the OpenMV Cam AE3. And now let's check out what that looks like. So let's grab a little browser window here, shrink that down, and see if we can detect some license plates. So let's go to Google Image Search and do license plates. And let's check out some license plates and see what happens. So we need to make sure that they're quite big. Okay, great. So now we got the camera running and see it pointing at a license plate there. Let's see if we can figure out what's going on in the image. It looks like it's detecting too many. It's not really centering on one of them. Getting some results. Okay, let's try if we can kind of clear out the background of random things. All right, there we go. It's finally detecting a license plate. Took it a little while. Pointing at a screen is challenging for the camera. Let's see if we can get some better results. Oh, there we go. Okay, great. Yeah, so as I mentioned, we just threw a model together and didn't put much effort into training it well. And so that's not going to work in the best case if you want really, really good results. As I mentioned, the accuracy was something on the order of 90%. And so that's a little bit too high, meaning the network kind of overfit on the data set. But you can still see it works. And so we're excited to announce this feature and see what folks are going to be able to do and how you guys are going to be able to train your own license plate detectors. What's going on here? There's some interesting cuts they have of the background of it. Yeah, but we're excited what folks are going to be able to do with this feature and how they can build their own AI models to detect whatever you want. And then these can be deployed on the OpenMV cam. So it's going to be an exciting future. Remember, this is the worst it's going to be. It's going to be better as we get everything more mature and etc. All right. Thank you for watching.